anyone who's worked in structural civil engineering knows that there's definitely a lot of aspiration to be better digitally. The reality, given the sort of, I guess, high risk nature of the work that's being done and the high stakes that exist on a construction project, it's kind of hard to digitize. It's hard for big companies to digitize. So you end up in this environment where you have different parts of that organization trying to digitize things, but other parts being resistant to that. In Arup, so I was kind of stuck in the middle of that. At my time at Arup, I did find my ways into the digital world of Arup and spent many overtime hour trying to build, Grasshopper scripts, building out Python automations, putting together reports for digital projects and this kind of stuff, which is where we cross paths. Good times. But eventually I just kind of got sick of the corporate environment, and I personally didn't sort of see the problem that CalTree is trying to solve and say, I definitely saw the problem, but I didn't say that's the one I want to solve. I just wanted to build a business, to be honest. I wanted to build a startup in the construction space that I understood, but I didn't know exactly what that was. So what I did was, during COVID, that was kind of like the catalyst for me. I was like, okay, life's short. I'm going to roll the dice and try and start something.
Hi, Tim. Welcome to the Digital Construction Podcast. How are you today?
Good, mate. How are you going?
Very good, very good. So in today's episode, we sit down with Tim Rawling. He's the co-founder and chief product officer of CalcTree. We want to explore how they are transforming the way engineers perform calculations and manage project data. We'll discuss with Tim the challenges of developing a no-code or low-code platform and how CalcTree improve efficiency and collaboration, and how the engineers are adopting this technology. But before we start, I'm very interested to understand an introduction of CalcTree, and I want to know, Tim, what inspired you and your co-founders to create and launch CalcTree, and also if you can share a little bit of your story.
For sure, yeah. I'll start with the platform itself, and then we can get into all the other stuff. So you can think of CalcTree as effectively like a workbench for your calculations. And in the sense that you might have an individual who is performing structural, civil, mechanical, engineering calculations, who needs to think through their work through like a back of envelope calculation first, but then eventually produce a report from that calculation. So CalcTree allows you to do both all in the one place, as well as actually execute your calculations like you might in Excel or with Python as well. The other key part of CalcTree is that every CalcTree page can be a Python script. So you can have your report or like manual calculations alongside a Python code. So looking to help engineers who are kind of getting into starting to use code to do their work, giving them the ability to spin up Python quickly in a web environment without having to install environments and all this kind of stuff, all in the one place. And I mentioned that's sort of in the context of an individual. It's also a collaborative environment. So when you have a workspace in CalcTree, you have an environment where you can add your team members to, and you can collaborate live on the platform and build out calculations together. And then with the aim to turn them into templates that can be reused. I think we've all seen, and I've experienced it myself back in the engineering world, you build up these kind of example projects, or you might have like a spreadsheet where everyone's like, oh yeah, that's the spreadsheet you use for whatever that calculation is. It's the same idea with CalcTree. You can turn any individual page or multiple groups of pages into templates on the platform, which can then be reused for different projects all in the platform itself. So yeah, hopefully that gives you a good sense for the product itself. We're all SaaS online platform kind of vibe. So kind of trying to bring some of the kind of modern software engineering tools like Notion, Obsidian, those kinds of tools, bring that kind of functionality into traditional engineering space as well.
But you're also the classic founder that comes from actually engineering.
Yeah,
I met you in the days back at Arup. Can you share us a little bit of your journey and
sure.
how you end up here working at CalcTree now?
Yeah, so I started. When I came out of uni, I actually started working at Accenture of all places. I was doing like digital. What was I doing? digital business consultant, I think was my role. So that was basically like management consulting, but for digital. So I was doing a lot of digital transformation projects for the likes of like Telstra, Optus, and these kind of guys, BHP and that sort of thing. But then at the same time, I was doing a master's degree in structural engineering. And at the end of that, decided to go into structural engineering because I wanted to build stuff, basically. I wanted to be involved in real projects where we built real things rather than just kind of building slide decks. No offense to any management consultants listening. But yeah, I ended up at Arup as a grad, but I always had like a digital bias because I just spent, a couple of years doing that, like assessing companies for their digital capabilities and figuring out ways to improve things digitally. And I think anyone who's worked in structural civil engineering knows that like there's definitely a lot of aspiration to be better digitally. The reality, given the sort of, I guess, high risk nature of the work that's being done and the high stakes that exist on a construction project, it's kind of hard to digitize. It's hard for big companies to digitize. So you end up in this environment where you have different parts of that organization trying to digitize things, but other parts being resistant to that. In Arup, so I was kind of stuck in the middle of that. At my time at Arup, I did find my ways into the digital world of Arup and spent many overtime hour trying to build, Grasshopper scripts, building out Python automations, putting together reports for digital projects and this kind of stuff, which is where we cross paths. Good times. But eventually I just kind of got sick of the corporate environment, and I personally didn't sort of see the problem that CalTree is trying to solve and say, I definitely saw the problem, but I didn't say that's the one I want to solve. I just wanted to build a business, to be honest. I wanted to build a startup in the construction space that I understood, but I didn't know exactly what that was. So what I did was, during COVID, that was kind of like the catalyst for me. I was like, okay, like life's short. I'm gonna roll the dice and try and start something. So I actually left and joined an incubator. So the incubator I did was with Antler. So Antler is like a global venture capital fund, and they run these incubators, they call it, where basically they'll bring in individuals or people who'd already started like a business, but they bring them into this environment, like a 12-week intensive course. They give you a bit of a stipend so you can live, so you can do it full time. And then you don't need to necessarily have like a full-on project or a full-on company idea to start or to get into Antler. So I went in just saying, I think I said I wanted to do like robotic reinforcement bar layouts. I wanted to like build a robot to like build all the rebar for a building core, which would have been really cool. But I very quickly learned that that's not necessarily a really good place to start your entrepreneurial career, just due to a whole bunch of difficulties. But through that Antler process, I met my co-founders. So Honor and Mahan are my co-founders. Mahan comes from a geotechnical engineering background, and he actually came into Antler with what was the original version of CalTree. He'd actually built a version of CalTree where it was more about like a hard-coded set of calculations. Imagine like a website where, kind of like if you've seen like OmniCalc, OmniCalculator and these kinds of things, where it's like hard-coded calculations in the page. And his idea was to just build out these like hard-coded calculations and then provide that to engineers. But when we kind of got together, I kind of saw how that actually could solve a lot of problems around how companies turn how engineering firms rather turn their IP that they work on projects into templates that can be reused. The missing part of what Mahan hadn't kind of put together at the start was like a way for engineers to actually build those tools. Because for his idea to work, you have to build in JavaScript or build in HTML, like those tools right away, which is not accessible for the average engineer. So where we landed was wanting to build a platform that allows engineers to do their work, but also capture it and turn it into templates, which can then be reused. And that's kind of where CalTree was born. So at the end of the Antler process, we then basically pitch their investment committee with the concept that you've come up with throughout the process. With your team, you have your pitch deck, maybe you have a prototype in our case. And then for us, we were actually successful in getting some seed money from Antler. And then, we went from there.
That's very interesting, and I'm sure that there are many engineers that dream about this change during their everyday tasks. They are designing, they are working as structural engineers, they're working as mechanical engineers. Pick any disciplines you like, and I know that many of them would like to do what you've done. You've been brave enough to actually do it, so congratulations to you. Well done.
Thank you. Yeah, I think it was definitely. I always wanted to start my own thing on the side. I actually did a like a little data analytics thing on the side in part-time, like trying to do both Arup, like work at Arup and do that at the same time. It was very difficult. And it was, I mean, as much as we all complain about COVID and lockdowns, if it weren't for that, for me, I probably never would have had the, the guts, the courage to actually just say, you know what, stuff it. I'm just going to roll the dice and see what happens. But yeah, that was my story. And that was actually a pretty big silver lining of that whole experience. But yeah, it's, I think everyone kind of sees those problems day to day and think, oh yeah, that should be a business that solves that. It's definitely been a rewarding, albeit very difficult and stressful experience to actually try and do that and live that concept.
Yeah, very nice. And thinking about the inefficiencies that you see in the engineering industry, the construction industries, and there is lots of inefficiency in workflows. We talk about it all the time in this industry. So what are, from your point of view, the biggest inefficiency, and which one are you trying to improve with CalcTree?
Yeah, I think, there's a few that we're trying to solve with CalcTree. I think the biggest issue that I see is like sort of it's like a two-sided thing or a two-step thing. And what I experience in structural engineering, and I think a lot of other engineers would have be living today, is the kind of what you say, like fragmentation of data across different tools. And so this was one of the things I remember back in engineering we kind of struggled with all the time, was like, how do I take data from this program, bring it over here, perform another operation on it, and then bring it over here and perform another operation on it? And how do I do that when like all these programs are, from different eras, let's say, have different data formats? And also, how do I do that if I can't code? That was kind of the biggest challenge. And the only solution you have in that environment is doing it manually. And manually looks like extracting data results or analysis results from something like a NETABS or something like that into a spreadsheet. Then writing a bunch of formulas in that spreadsheet, or manually moving data around, and then maybe copy pasting that into another spreadsheet, and then maybe exporting some of those results, putting it in Bluebeam, or putting it into like another calculation software to make some decisions. And that like multi-step process where it's manual data handling every time, I think that is one of the biggest problems in the industry, because in the first instance, it's very time consuming. And, it's a lot of time as an engineer spent not actually doing design. You're just kind of manipulating, wrangling data to make decisions. So that's, in terms of like the lived experience, I'm an engineer, that just sucks. And like, it shouldn't be where we're spending lots of our time. But the other big problem from a sort of corporate governance perspective is how do you make sure that no one's making mistakes? Like, it's one thing to get your calculation right and make sure that, your design has the right amount of rebar in it. Or you're using like the right kind of structural system for a particular problem. That's challenging enough as it is. But add into that, the risk of just screwing up an Excel document, like actually putting the wrong column next to the other, like another wrong column, and all of a sudden you're working with incorrect data, and then multiply that 2 or 3 times across every kind of design task that you're doing. The chance that someone makes a mistake is like extremely high. And so, yeah, I think that's the biggest problem, and that's where we're working on, where we're focused on for now, solving with CalTree.
No, that's great, thanks. And I would really like to talk about the challenges in developing software for engineers, particularly in the construction industry. I remember a while ago, somebody said to me that tools are like toothbrush. For engineers, everybody needs one, but nobody wants to use each other's toothbrush or something along that line. Yeah. So it's very hard to develop software for engineers, because typically they think that they know how to build software, or you need to balance the user friendliness. So it's tools that needs to be user friendly enough, but also technically accurate. Yeah. So what are the biggest challenges that your team has faced when you started developing CalcTree?
Yeah, Really good question. And I think engineers as a group, any type of engineer, software, structural, mechanical, whatever it is, like there's definitely like I know the answer, or I can figure out the answer better than you can. Like that's definitely an attitude that I've seen in industry and probably have projected myself. So I think the biggest, we have a saying internally or we kind of have call it like a pub test or a litmus test when we're trying to make a product decision. We say, oh, are we taking a position, or do we have an opinion on how this part of the product should work? Or are we going to let the user make the decision? And why that's challenging is because it's much simpler from a technical software development perspective to just take a position on something and say, this is how it should operate, and that's how we're going to build it, because it removes a lot of complexity and ambiguity in how you might then build that aspect of the product. But then you run into this issue when you give it to a user and they're like, oh, actually, I don't agree with the decision that's been made there, or I don't have enough information about this aspect of the product to use it effectively. I don't like it. I'm not going to use it. And so I think that's one of the biggest consistent challenges we've had, is when to take a position on something and when to take the extra time to build the optionality into the product. A good example of this was in CalTree, you set up a bunch of parameters, right? And those parameters are kind of like cells in an Excel notebook. You feed data into them and they perform an operation, or they, are an input to a calculation or whatever it is. And you have to give them a unique name. Not a unique name, but like a name that's code friendly, which means it can be then used via API and referenced in Python and all this kind of stuff. And so initially we took a position that, we are just going to if there's duplicates in these names, we're going to sequentially add numbers to them and sort of control how those parameters get named so that the user doesn't have to worry about it. But then when we gave that to a user, they were like, well, how come I don't want that name to have an _1 at the end of it? I want it to be blah. I want it to be blah. And we were like, well, how do we give them the ability to do that, but then not have to build crazy systems, right? And then we realized the answer was to just give the user more information, and give them warnings if they have duplicate names and this kind of stuff. And so that was where we took a position, but actually we should have just given the user more information or given them the option. And doing that consistently across the product in a new kind of way of working, the CalTree is probably the biggest challenge I think we've faced. And then doing it in a way, like you say, that's user friendly and not so much information that it's just overwhelming and they're like, oh, what the hell? I can't deal with this. See you later. Getting that balance right is tough.
Yeah, definitely. And we also know that engineers are often familiar with manual workflows. I don't know if we want to consider Excel a manual workflow potentially, but how do you address the skepticisms from engineers that they still want to use their traditional or manual workflows?
Yeah, that's another good question. I think there's two aspects to that, which one of them we have always focused on since the beginning of CalTree. It was one of our principles. Another one which I'll get to second, is we learned it along the way. And the first one is transparency in the product. I think there's a lot of products out there which are kind of what the industry would say black boxy, where they take some input, they do some stuff that you don't see behind the scenes, and then they give you the answer. And I think engineers, when they see a black box, it's alarm bells. That immediately is a turn off. And so we, from the very beginning, wanted the product to be ultra transparent, and we wanted people to be able to look at a page, look at the integrations of a page, so the mechanics underlying a page, which are currently Python script, and then be able to understand and decipher it, in a language that they understand. So we wanted to remove that black box, and I think that's gone a long way to one, differentiating us to some competitors and existing tools, but also to making new users more comfortable, because it's you're in CalTree, it's a new environment, but you can always look at the integrations and then see an environment that you're familiar with and get that transparency. So that helps. The other one, which is a lesson we learned, was we're better off integrating with and playing with existing tooling rather than replacing certain tools. So at the beginning, I think we definitely had part of our vision was we're going to ingest Excel spreadsheets, and then you can use them as sources in our pages. And then that's how we're going to work with Excel. And that we still want to do that, but we kind of learned that one, that is technically extremely hard because Excel, you know, the legacy systems and frameworks that Excel uses to build a platform that can talk to all of them, and it can talk to Excel 1998 and Excel 2015 and use both and work with both of them the same. It's like extremely challenging and very resource intensive from like a software engineering perspective. So that was, you know, one reason. But the other reason was that we found that engineers, in a lot of cases, just wanted to stay in their existing environment. They wanted to stay in Excel. They wanted the benefits of CalTree, but they still wanted like a lot of their workflow to happen in Excel. And this is particularly apparent for like large organizations where you have groups of engineers. You have to consider their needs. You can't just say to everybody, you're all using CalTree now. Some people are going to be like, no, stuff you, I'm still going to use Excel. In fact, a lot of people are like that. So we kind of have, over the last maybe 12 to 18 months, have started to focus more on how we integrate with Excel. And so that looks like building plugins, building tutorials that like bridge, or building workflows rather in the app that bridge across tools. We're focused on doing that more and more as well, which is helping dealing with some of that skepticism as well, because it gives people in an organization who aren't interested in CalTree or want to stay in Excel a pathway to do that, but the organization can still get a lot of value out of the platform because they can kind of have their central repository of tools, which have been built up by power users and they trust, and they've been vetted and gone through QA processes. But, you know, Mr. Engineer over here can keep using Excel. They just reference that page as a formula, basically. So, yeah, those are the two big things, transparency and integration.
Yeah, that's very good. And you probably touched a little bit on the evolution of CalcTree, and you already mentioned that your co-founder started something and then you guys worked together. But I'll be interested to know how has CalcTree evolved over time from the original, the initial release.
Yeah.
What have you done? So how did you evolve?
Yeah, I mean, there's a lot of aspects to that. I mean, I guess you could talk about it both in terms of like the business and then in terms of the product itself. I think in terms of the product, where we started, I touched on it there earlier, was Mahan had built just like a web page, which he basically effectively hard-coded calculation logic into a web page, and then that was the calculator. And that's, you know, what you'd see on like I said, like OmniCalc and other tools like that. And where we've gotten to now is a product that engineers can build that in a no-code environment and then share it as a template. And there's aspirations to have a marketplace as well, where an engineer could build something, turn it into a template, and then it exists on a marketplace, either privately within a company or publicly for the world to use. So yeah, that obviously there's a lot of evolutions in the product. I think one thing that we did at the start that was probably a case of biting off more than we could chew was we tried to. So in CalTree, you have integration. So I've talked about both of them already, but to explicitly say, you have Python integration, which means on a page, you have like a page, like imagine like a Google Doc, and then you can like pull up a screen where you can start to type and write Python. In the past, we actually also had that for Excel, where you could actually open up an Excel editor and then also edit Excel. So the idea being that you can have your report next to your Excel and your Python next to your report. That was extremely complex, and it added a lot of overhead into the requirements of what we're developing. And we, by all means, still intend to do that. But yeah, about like maybe 6 months ago, we basically hid that Excel integration part of the product so that we could focus on making a really good page experience and really good Python experience. And we also at the same time shifted, and I talked about it on the last question, shifted our strategy with Excel from trying to like ingest Excel and more about like building a really high quality plugin for Excel, which can then bridge the gap between the two. So we're kind of, that's probably been the biggest change, I would say, in the product. And then in terms of the company, I think the biggest one is probably how we, like our go-to-market strategy. I think we maybe naively at the beginning thought that we could do product led and we want to use SEO to reach the market and then use self-serve sign up to get people onto the product. And I still think that in the longer term vision of CalTree is still very viable and definitely what we're pursuing. But particularly in the short term, when we're trying to basically launch a new product into the market and convince people that, there's this new way of working is value adding to you, there's that kind of the challenges that come with that lend itself more to a B2B sales process where you're jumping on calls with people from firms, showing them the product live, having like an ongoing discussion, taking their feedback on board, maybe making some changes to the product, maybe building out some examples, and then coming back to them and then rinse and repeat until you get like formal trial users and then signups and paying users. So yeah, that's probably been the biggest change I think in the business as well. As well as obviously scaling up the team. We started with just the 3 founders. We now have 9 in total, so 5 full-time engineers, full-time software engineers, and then a structural engineer as well, and then the 3 founders.
That's great, and I know startups are continuously evolving. If I ask you this question in 6 months from now, you'll probably have...
Ask me in a week, and there'll be different.
Yeah. Definitely. And you touched before on the black box nature of some of the products that exist in this type of market. And I agree with you, engineers immediately don't trust them because, of course, it makes sense. Like they are responsible for the calculations that they deliver. So, but from your point of view, how can people use CalcTree at the same time, make sure that the calculations they're producing are reliable and accurate as well?
Yeah, so I think what CalTree is really strong at in the current state, and we'll get stronger at, is it's really clean and it pushes you to lay out your calculation in a logical way. I mean, if you really tried, you could make it confusing. But just the nature of the way that you add blocks to the platform and start to build out your calculation, and also the way that we present math notation in the platform as well, it makes it very hard to not notice a mistake as long as you know what you're doing. So it's baked into the product that as you build, you are kind of also building your documentation. It's not like you're just like doing something on the back of an envelope, making some assumptions, and then that's job done. And it's not like you're just in Excel where maybe you're referencing other sheets, which are just with cell references and this kind of thing. In CalTree, when you write maths, you have to reference the name of a parameter. And when your maths renders, like when you click off it and it renders in math notation. So you can see if your maths is wrong or not in plain maths, not in code. And I think those 2 things help and encourage people to document as they're doing their calculations, which is how you avoid mistakes. You do good documentation, you can work with collaboratively with others, or come back and see logically like what's happened. And yeah, CalTree helps engineers do that without adding extra burden to them. I kind of think of it like imagine you're writing code and you don't have to write your own comments. They're just kind of like the way that you set up your code actually just does the commenting for you. It's like, okay, this logically makes sense just by looking at it. And you don't have to be a software engineer. You can just be a regular engineer who's only ever used Excel, as long as you understand maths to understand what's going on. Additionally, and I touched on before, our integrations you can just always click them and view them in the page. If they don't ever get hidden. So anyone who's on a page can view the source integration on the page, and then understand the logic within that as well. So yeah, that's kind of our guiding principles drive the engineer as they're doing their work to create that documentation. And that I think is key to making a good template as well. So if you want to make a good Excel template, any good Excel template, if someone says, oh, this Excel template is really good, why is it good? Well, 1, it's right. And 2, it's got documentation. It's got the clause reference that it's talking to. It's got, this, that, and whatever to explain the maths that's going on. In CalTree, as you create your standard work, as you're doing your day-to-day, you're getting all that stuff as well. And as a result, your work that you've just thrown together can also be a template. Because it's at that level where it's documented well and can be picked up and used by someone else. So yeah, that's kind of our approach there. It's helping get good documentation and transparency in the product features.
Yeah, definitely. And we touched a little bit before, in a way, about adoption. So sometimes we think it's hard to build software, which is already hard enough, but sometimes it's harder to drive adoption of digital products. Do you have can you share with us any unexpected challenges that you find in trying to convince firms to switch to a new platform?
For sure. Yeah, I think there's plenty. I just got to think about which ones to share. I think unexpected, well, like I kind of touched on before, like we thought that we'd be able to do like a product-led growth kind of strategy where, we'd build the product, we'd build SEO as well, build some templates, and then people would kind of just find their way and sign up. One thing that I found interesting in this industry is that I feel like some larger firms have maybe like compartmentalized curiosity or experimentation. So large companies might have like digital teams, and it's the digital team's responsibility to go out and find the new tools and then bring the tools into engineers. And the reverse symptom, I guess, or the result of that is that you might talk to an engineer and they're like, yeah, this is a cool tool. Like I can see it being valuable, but it's not up to me whether or not I can actually use it. So I'm not interested, which I think is like, I just didn't expect that. Because I mean, my personal experience, maybe I was kind of more digitally inclined and I would be open to using new tools. Like I just add a new plugin to Grasshopper and like get going with it. But I found that, with the majority of people, it's kind of like, oh, well, like I'm not even going to waste my time talking to you unless you talk to like the digital team and you go through XYZ process. And that's part of that finding, I guess, was part of the reason we switched to B2B. But at the beginning, I mean, I think now I've thought about it a lot and I think it makes sense. But at the beginning, I thought that was, quite surprising. I think the other thing is like in the product design itself. And again, I touched on it before with the kind of like when to take a position and when to like provide information to a user. I didn't appreciate how important getting that balance right was to someone adopting the product, because on the one hand, if you provide the user with a million switches and dials so that they can customize the experience to how they want it, that's great. But most people are kind of like, too much. Like that's too much. I don't care. Like I don't immediately. I'm turned off by this. I'm out. See ya. But then on the reverse side, if you don't provide some degree of the ability to customize or like just providing the information so the user can make the right decision about a certain situation, then they also get annoyed, because it's like you're in black box territory, right? So getting that balance right, I did not appreciate at all. And now when I look at other products and I kind of see where they've had to kind of balance that, I have like a newfound respect for that sort of thing. And yes, it's no different for us. And one of the biggest challenges we have, the challenge with it is like with that sales cycle stuff, like it's quite easy to get feedback. Like we figured it out pretty quickly that this probably isn't going to work. But with this product design stuff, it's really like, it takes a long time to know if you got it right or not. And there's some stuff in the product that I still don't know if we got right or not, because it requires people to use it. You start a dialogue with them. You have to read between the lines of how they're using it, what they do like, what they don't like, to understand whether or not the decision about, having a toggle over there or having a warning show here or whatever, to know if that was correct or not. It costs money or it costs time and resource to like execute on the decision. And then it takes like quite a lot of time to actually get feedback on the decision before you can get better at those sorts of things in future. So that's, I think most product people, like from tech in particular, probably are like, obviously. But from where I was coming from the structural engineering world, it was kind of like, what? This is like, I didn't even think this was something that you needed to figure out. So that's been, that's challenging. And the reason I bring it up in the context of adoption is because if you get it wrong, see you later. That people will very quickly, particularly again, consulting engineers who are, working on by the hour, they're working to heavy deadlines. They don't have spare time. And the moment you make them think more than they would like to about certain things, then they'll go back to Excel or go back to whatever their existing workflow was.
Yeah, definitely. There is no time to understand the new products, and it's so challenging because sometimes people miss opportunities because they may have a fantastic tool in front of them that could really improve the quality of their life because they could work more efficiently, and they just dismiss it because there is so much going on, so many products available in the market.
And our kind of position on that is that like, well, if that's the result, then we haven't done a good enough job as product designers. Like the product should be part of a good product is something that someone can pick up, and whether they're designing a spaceship or like picking what to watch on Wednesday night on Netflix, like it should be obvious what they should do to get going and get started. Now, obviously, with a more complex thing, there's additional layers that need to happen there. But yeah, I mean, our belief and at the standard that we measure ourselves by is that, every time we have to add more documentation or add tooltips and this kind of thing, then we haven't done a good enough job in making the product intuitive or balancing that information versus opinion. And yeah, so that's just part of the challenge, isn't it? And yeah, it's like you say, it's a shame because, if you move the needle slightly in one direction or slightly further away from the user, i.e. you're not as good as you would like to be, then you potentially lose that user. It's not on the user to put in the effort to try the product. It's on you to make the product so easy to use that they want to use it. Like that's trying to like how we think about it, but it makes it hard. It's obviously very hard set of goalposts.
Yeah, definitely. And if we think about the users, who are the primary users of CalcTree?
So yeah, I mean, we're focused on structural engineers globally. I mean, I guess primarily focused on Australia, US, and Euro markets because that's where our backgrounds are. So that's where we're focusing. We also feel like, and maybe this was the wrong decision, but we also kind of feel like that in terms of like the complexity of design, that is one of the like higher complexity ones, and reporting in terms of like what they have to do compared to like maybe geotech or mechanical in certain industries. But of course, this probably comes down to my knowledge, and I was a structural engineer, right? So that's who we're focused on, and that's primarily who our users are now. The vision for the product is any traditional, i.e. non-software engineer performing technical calculations who has to do reporting. They would be a target user for us.
Yeah, definitely. And later on, you can expand on any other discipline, but the structural engineering teams are already big enough. So if you can convince them, there will be a good result.
Definitely. Yeah. That's like what we're basing it on.
Yeah, one of the things that I know CalcTree does is it allows people to reuse calculations from different projects, so you don't have to reinvent the wheel every time. Yep. Can you share with us how people can use CalcTree to improve collaborations between engineering teams or different projects? How can they do that?
So the way CalcTree is set up with a set of pages, basically, and those pages are grouped by branches, which are themselves pages. So a better explanation would be if you've used Notion page branches, then that's the same for CalcTree. So you can basically set up a page, which is a template, and you might just have one page, which has, this is my calculation for designing an RC beam to whatever code. That page can then be duplicated and moved around the platform. So it can be moved into another branch, which might be called, say, templates, or it can be moved into another branch called exemplar calculations or this kind of thing. As well as just at the individual page level, you can do the same for multi-pages. So you might have a group of pages which can speak to each other and perform not just the design of an RC beam, but the design of an entire floor plate with the one-way slab, your RC beam, and maybe your column connections as well. And that might be in one pack. And the connections between the two, or between all the different aspects of that calculation, are built into that package of calculations. You can then duplicate that group of pages, and then also move them into a template environment. And so then what that allows you to do by doing it that way is that you can use your building blocks just as you're going. You can have your different building blocks of your project, different calculations, but then as you group them together to deliver your work, then they become bigger building blocks. And so they are all templates that can be duplicated, moved around, permissions adjusted, and then reused as calculations. So we'll try to keep the platform quite flexible in that way, because again, this comes back to that kind of opinion versus giving the flexibility. And we decided to try and keep the platform as flexible as possible, because every engineering team's workflow is slightly different. Every project is slightly different. And therefore, as well as having to do slightly different calculations, you also may have to have slightly different structures. So this allows you to have different structures of calculations or groups of calculations, which in themselves can become templates.
Yeah, that's great. I would like to talk about the future. Like, it's very hard to predict the future, and nobody really can, right?
Yeah.
But if you think about the engineers, the software for engineers in general, how do you see this space evolving in the next, let's say, 5 to 10 years?
Yeah, I mean, I think there's many reasons why that's tough. I think the biggest reason is going to be my answer, and that's AI, because the rate of change of that technology is just insane, and I think it's just the beginning. I think our industry is maybe going to be a slower adopter of that tooling, but nonetheless, we'll eventually adopt AI tooling, and what exactly that looks like. I have some ideas, and we're very much looking at how we're using it in CalTree. We nudge. Maybe that's what's coming in future. I think every existing product that's still going to be around in 10 years will have some kind of AI feature in it. Now that's a broad spectrum, right? It could be something as simple as like a gimmicky, really just a wrapping of ChatGPT in a chatbot in a product, but it could also then be something. You mentioned, I think earlier, about drones that can assess buildings, this kind of thing, and that's using AI to categorize and identify problems. So that's kind of the other spectrum of AI. Will we have a situation where in a CalTree you might have a whole bunch of building templates? Then when you get a new project, you actually just ask the AI, based on our templates, produce a new project structure for this new project that we're doing. It's hard to say, impossible to say exactly how AI will change how people, how our products exist and how people work with those products. But I think in almost all facets, it will change it, for better or for worse. Maybe Skynet's on the way. Maybe it's inevitable. We'll see. And I think a subset of AI is agents. I think, closer to home in the context of a CalTree, or the problem that I was talking about at the beginning about data fragmentation, moving data around. I think we're going to see AI agents which eliminate that problem. Basically, I don't necessarily think that we're going to replace a full suite of software tools, like structural engineering software tools, with one tool. I think rather what you'll have something which glues it all together, and using AI agents. And we're hoping that will be something like a CalTree, where we help you build those integrations and flow data across the tools that you're still comfortable with, so that you maintain transparency and you don't have black box. So I think that will be a big part of it as well. I throw in generative design there as well. I still think in 5 to 10 years it'll be just giving you a baseline. I still think engineers will be making the final calls on things. Kind of think of it you might use ChatGPT to draft an email or draft a documentation page or draft a report, but it's rare that you would just send that as the final version. You're probably going to take that baseline and then make some edits and adjust it. I think we'll see that same kind of thing with generative design as well.
Yeah, it's hard to predict where this is going, because we have seen the evolution of products like ChatGPT. It's been so quick. We were so shocked the first time we saw ChatGPT, and now it's just normal. Yeah. It's incredible. So it's very hard to predict what can possibly happen in the next 5, 10 years without being able to see the roadmap of these companies, which is probably very secret now.
Who knows? Yeah, it could go anywhere. I hope it results in some kind of robotics, not Skynet, but maybe something like Skynet. Building buildings automatically, this kind of thing. I would love to see that.
Back to the origin where you started, right? You wanted to be a robot at the beginning.
Exactly.
Your dreams come true.
It's still on the roadmap. It's just really far away. Yeah.
Just for later.
Yeah.
And speaking about roadmaps, what next for CalcTree?
Yeah, good question. So right now, what we're really focused on, like the predominant feedback we're getting from engineers is that in the context of like the web environment, CalcTree does a good job of helping you document your calculations, lay things out more logically, and then our APIs and integrations with other tools really make it easy to use what's in CalcTree in other tools, which is awesome. But where we kind of have been falling down and what we're focused on right now is improving how CalcTree translates into reports and PDF reports. We always wanted to, the dream was that, you know, if you just shared a CalcTree link with someone, you wouldn't need to PDF a report. That was wrong. Like we need, people want PDFs, you know, just as much as they want Excel. And that's fine. So we've been doing a lot of work improving the platform from the perspective of how is this going to realize itself in a report. So that's right now. And that's kind of stuff like, honestly, like not the sexiest stuff, but stuff that needs to happen. Things like headers, adding logos to headers, margins, font size, this kind of stuff. So that's what's happening now. After that, what we'll be focusing on is basically where one of like in CalcTree, there's like a right-hand side panel, which is where you kind of have all your different like components for doing stuff with the page. So currently that's where you would add like a source or a Python integration. And that's where you would manage all the parameters on your page. We're starting to do work on changing that infrastructure so that it's easy for others to build on top of it. And in the first instance, we'll be building our own kind of, we call it side panels, building our own side panels that do cool stuff. The first one that will be coming out is version history and review history. So every page in CalcTree, it actually already has this under the hood. It's just not visible in the UI, but every page has full version history. So the moment you start a page, it starts at version 1, and every time you make a change, we group them, but effectively there's a new version that's made. And so that sidebar will allow users to go through and see older versions of their calculations, and then eventually be able to like compare side by side, not just the content on the page, but also the actual calculation. So if you had like Python code or an Excel spreadsheet, you could compare what changed in that as well. And then on top of that, we'll have reviews. So you can send a version for a review. So basically in the platform, you can say, okay, I finished my calculation for my RC beam. I want to send that to my manager. I then tag them or set them as the checker for this calculation. That then automatically sets off that page into a QA process. That manager then gets a notification, hey, you've been set as the checker on this calculation. They come in and then they basically have to go through going through and commenting, or they can comment on a page, comment on a calculation, say, hey, this is good, needs to be updated, whatever. And then they would tick done, like, okay, we've checked this. And at that point, that page is now labeled as reviewed. And that review status is shown everywhere else in the platform. So this is how we start to add that kind of, call it like light project management into the calculations as well. Then after that, like, honestly, we take it, it's hard to, we have aspirations, but we kind of, like one of the aspirations, for example, is then integrating AI.
Thank you very much, Tim. We are at the end of the episode. If people want to reach out to you, where can they find you?
Yeah, so you can always head to our website, caltree.com. From there, you can view all our template libraries, sign up to the platform or book demos with us. Additionally, we're pretty active on LinkedIn. I think at CalTree would be our tag on LinkedIn, so you can hit us up there. Always keen to hear from everybody and show you the platform or chat more about anything specific that you've heard on this episode.
Thank you. Thank you very much, Tim.
No worries.